In example 2, we've got a series of complex numbers and we're asked to write it in the form a plus bi. So it makes it really clear what's the real part and what's the imaginary part, the coefficient of I. And we've got this condition here that a and b have to be real numbers. So this part here means that a and b are just ordinary real numbers. So let's look at part A. We can treat I exactly like we would any other constant, and we're just going to collect together the real parts and the imaginary parts. So here we could write this as 2 plus 7, and we could take I outside of a bracket out of these terms, 5i and plus 3i, and we could write that as 5 plus 3i. So you could write that as 9 plus 8i. So this is actually a complex number with real part 9 and imaginary part 8. Let's look at B. I'm going to expand out this bracket, so I'm going to write that as 2 minus 5i, and then minus 5 and plus 11i. And I'm going to collect together the real parts, so I'm going to do 2 minus 5, which is minus 3. And then I'm going to do minus 5i plus 11i, collect together those terms, and I'm going to get plus 6i. So this is a complex number with real part minus 3 and imaginary part 6. In C, I'm going to expand the bracket, so I'm going to write that as 10 minus 16i, and then I'm actually done. Real part's 10, imaginary part would be minus 16, the coefficient of I. And in D, I'm going to split this up into two fractions added together. So I'm going to write that as 10 over 2 plus 6 over 2 times I. So I can write that as 5 plus 3i.